All right. Cool. So we are at episode 10, or stream 10, or however you want to categorize these. Last time we did a lot of stuff, and we got the game working to the point where we could have a start screen, and when you press start, it actually made the ship appear, and the background it's kind of scrolling on its own, and if you hit start again, it pauses the game, and if you hit start, it resumes the game. And we talked about essentially at this point having all this data kind of being hand coded into the assembly, and that we should build some tools. And after asking everybody on the stream what they thought, sounded like we wanted to build the tool on stream rather than me doing it independently of the stream. So that's what we're going to do. And I don't know how successful this is going to go, given that we're kind of branching out of the NES programming side of things, but I think it'll be cool. I'm excited to work on this because it's going to be a little bit different, and it should go, I think, faster than what we were doing before. And then once we kind of have things working, we'll have a nice tool that we can use and potentially share with others who want to use it for their games. We'll see. I mean, I'm not sure I'm not sure how useful it'll be to others, but we can do our best and see what we can build here. So I'm going to call this the NES asset tool. I think that's fine. It's a pretty generic name, obviously, but we're still kind of figuring out what we want to do with it. Put that under projects. I mean, we know, right, basically what we want to do with it. We have the tools, the tiles that we want to be able to display and deduplicate and check the colors and check the number of palettes and all of that stuff, where if we select multiple items, make sure that they'll be able to coexist on the screen as we expect, and probably and I guess additionally build the level in the in this tool and have it do all of that checking as we work on adding more tiles and building the level. So why are we in Visual Studio? We are in Visual Studio because I'm going to be using C, maybe a little bit of C++ here to actually build this tool. I'd contemplated going sort of full banana cakes and actually directly using Direct3D or OpenGL to do this, but it's just, I think it's going to be too much. For one, I haven't used it in a long time, so I think it would take me a while, and I'd be introducing errors and problems into the tool as we went too frequently. And then the other thing is that it'd be nice if it were cross-platform, and so I had contemplated using Dear I Am GUI, just because it's a great library for immediate mode GUI drawing for any sort of tool. And again, that kind of requires the use of OpenGL or Direct3D or more advanced graphics library, or support for 3D graphics and stuff like that. And obviously we're not doing anything in 3D, so I thought that maybe what would make more sense is we use here it is. We use this, I've talked about this a little bit before, this Tigger library. It's a simple graphics library that is cross-platform, Mac and Mac and PC, and would allow us to draw what we need, and might be kind of cool to actually build the user interface components ourselves. Just this way the tool is consistent across platforms rather than being something that looks different on different platforms depending on how we've built it. And I mean, we'll see. I'm thinking probably too far ahead of what we need to right now, but let's get started, and then we can see where this takes us in this stream. I have some ideas of where we need to go to do this. I'm not going completely cold into this, but it's still gonna be interesting. And you know, I am gonna base a lot of what we're doing off of Dear IM GUI to some extent, and you know, I guess you could argue that this may be more work than using OpenGL or Direct3D, but at the same point, it's going to be really obvious what we're doing, because we're gonna you know, do it right on screen, and it's going to be super easy to understand because it's all going to just be 2D drawing instead of trying to do the stuff in 3D and rendering the 2D assets in 3D using OpenGL. So let's get started. Enough of my rambling. So I'm going to get rid of these files that Visual Studio creates because I don't really care about the precompiled headers at all. They do not really do that much for what we're going to be doing, and what I've found, at least in my previous job, was, or not what I found specifically, but what we found in my previous job was that the fastest way to compile a bunch of C code is not actually with the precompiled headers, but to actually just include all your source into one file using include. We had a pretty large project that had a large number of automatically generated C++ classes. It used a definition file that generated a corresponding C++ class that then was compiled into a library that was used by our project. And with precompiled headers, it was definitely faster than just doing a single doing the compilation of the C++ without the precompiled headers, but it was nowhere near as fast as when we just included all those C files directly in one .cpp file and compiled that as a single unit, even with multi-processor compilation turned on. So, all right. So the first thing we need to do is I'm going to, I was cheating and testing some ideas out earlier. I'm going to pull the files we need for Tigger from here because I don't need to re-download them again. So I'm just putting these here in this folder. I wish Visual Studio was like other tools and just recognized that you put them in and then let you decide if you didn't want them there or not. All right, so we have these files in here. We just got to make sure that this is not trying to use precompiled headers. Good. All right, and then the only other thing we got to do is we have to include D3D, Direct3D library in the linker. Great, and that compiled. Now it's not going to do anything exciting. If you look at the example he gives in his documentation here, it's pretty straightforward to get a screen. So it helps if I include that header file. So I'm just going to kind of jump into this first and then talk about what we're doing and why. What was that called? while I'm looking at this and just getting this basic example working, I want to mention that I found out about this. I think I've mentioned it before, but I'll mention it again, from Kasumi on Nintendo Age. He's also on NestDev as well, I believe under the same name. So thanks for bringing this up, because it's a pretty cool little library and very easy to use and understand, which is kind of neat. So right away what I'm going to do is I am going to define some constants for colors. We'll probably move these out of here, but that's fine for now. So it has some helper functions for defining colors via RGB. May want to, well, we'll talk about that later. All right, so destination is screen. The font, there's a default font that it loads called named Tfont, and then just put this on the screen in white. Actually, so then let's do a different color. Let's do light gray. Still haven't figured out what's going on with my keyboard. Honestly, I haven't spent that much time on it, so it's not surprising. So I made that light gray so that we can use, oops, I reversed what I wanted to do, so that we can use white font. And then you do an update, and too few arguments and call. Oh yeah, we got to tell it what we want it to print. Hello, world. And there it is with our tiny font, and it's working fine. I'm going to make the window default size bigger. Okay, cool. So what is this all doing? So this is creating a window that's 800 by 600 with a title NES asset tool. This flag, this auto flag, is telling it that the size, that the window size should be treated as automatically adjusted. So if I do this, for example, not just get rid of it because it's not optional. If I change that flag to 0, then basically it's going to make the interior part be a fixed size, which is not what we want. I want it to be automatically sized to the window. And so then basically it's saying, okay, while that window isn't closed, clear the screen with light gray, draw the text hello world, and then update the screen. Right? Really, really straightforward, super simple. Pretty cool. It has some functionality for mouse detection and stuff like that, and it's cross-platform. So where are we going from here? I guess first, if anybody has any questions as I'm going, and just type it in the chat. I'll glance over occasionally and try to address them, especially since we're doing something totally different from assembly language programming. Hopefully this will be a little bit easier to follow because it'll be higher level, but I know we'll have some questions as we go. So what is an immediate mode GUI? An immediate mode GUI is a GUI that gets drawn by a series of commands. So typically when you're building something like in C# or Visual Studio in C++, I can even show you that as a comparison. typically you get a design tool, right? So if you just bring this up so you can see, an MFC has sort of a nice example of this. So if we go to a dialogue-based application, what you'll see is that Visual Studio will give you a window, and you just drag and drop components onto it. Once Visual Studio actually does something and finishes and lets me do it. All right. So, wow, they've changed this since the last time I've used it. Where is my actual window here? I would have thought this would be it, but interesting. Here we go. Well, sorry, it's been a while since I've built an app in MFC, so forgot where everything got placed. So anyway, so like I was saying, you have a window, and you do things like you grab your static text and you say, you know, assets, and then you get something like a list control, and you drag that on and you resize that, and then you configure it. And if you want to, you know, do something where you manipulate its behavior, default JS. Well, that's cool. That's great, Visual Studio. Thank you. You can do things like you can create methods to handle different things that it does. That the control does. You can create derived classes for the controls that handle different events and behaviors and the redraw and all that stuff. And you know, while that works and it's, you know, it's fine, it's not exactly a straightforward approach, and it takes some getting used to. And you know, about the only thing that I have to recommend this, the only thing I would say that to recommend this is that it's a visual design tool, right? You have the ability to drag and drop stuff onto this canvas essentially that you're using to build your application, which is fine. It you know, it works, and it's nice to be able to see. But the problem is that the code that's doing all of this is completely it's a complete black box, right? You really don't know how it's doing any of the stuff it's doing. You don't really have fine-grained control over it, and what's more, it adds a huge layer of complexity to the way that you're building your application. And you can do this stuff without MFC, but it's actually probably even more complex in some ways, because then you're dealing with things like the Windows event loop and handling different Windows messages that come in as you you know, you manipulate the controls, and the controls have state that they maintain. And I think realistically what I like about an immediate mode interface is that it's literally just you drawing a representation of a model of what you're interacting with. It's and you're doing it every time, and there's no retained memory of what was there previously within the interface itself. The interface doesn't know from frame to frame if it was checked or unchecked, and in fact you can, you know, completely change things very easily, because every frame you're directing the interface framework how to render the interface. And then that makes the code to do that pretty straightforward, or at least it does in an immediate mode GUI where the person who wrote it, has a lot of experience doing that. We'll see how ours turns out. Hopefully it won't be too crazy. I'm going to, sort of liberally borrow from IMGUI, I think, in terms of the methodologies that it uses for how to handle GUI representation. But I'm sure ours will be different, and we'll have our own interesting challenges as we go forward. But that's what's going to be kind of cool. And I don't think we'll be, or at least I hope we won't spend too many streams on this. I'm hoping that we get something sort of minimally working for what we want to be able to do. Like, we start with import a PNG for an enemy and be able to draw bounding boxes and save that, and then actually implement that into the NES code, and then come back and start looking at tile optimization, and then start looking at the world or the level building process of that scrolling level, so that we're not just pounding away in C and C++ and ignoring the assembly side of things, which arguably is more fun because we're actually working on the game. But the tools are important, and good tools mean you get the game stuff done faster. All right, so hopefully that explanation of the immediate mode is clear. And so when you're talking about user interfaces, you generally, you have your window, which is what contains your application, and then you have essentially containers and controls, right? The containers are controls, but they're a special kind of control, right? So you have a container like on the left hand side, which has a list of selectable items, right? And then you can have maybe something on the right-hand side, which is a container of, a graphical display for your PNG. And then you might have individual buttons, which are controls. They're not generally containers, but, specialized buttons might be containers, and they might have something within the button that's, that's not just a bit of text or an image. So the way that I was thinking about this when I was kind of preparing for how we were going to build this, what I'm thinking is that essentially the user interface is almost like it's almost like a stack of components, right? You have at the top of the stack, or you can even think of it almost as like layers in Photoshop. Let's draw it that way first, right? So at the backmost layer, you have your main window, right? And then within that, you have your list layer, right? Which might have within that a button, which might within that have an image, and then similarly, at the same level, you might have over here another control with other nested controls and components. And now that I think about that, that means that a stack really isn't sufficient to represent this, because a stack would only allow you to have, I'm going to draw, thank you, only have like a single layer of things. What you really need to be able to do is essentially have a tree where this is the root, component, that's another component, that's another component, and you're building this tree of components. And then once you're done, you're flattening this, right? So you're taking these components and flattening it down into this, and then and you're recursively doing that up to the root node. And once you're done, you've composited your final user interface. Does that make sense? Now, this might be completely wrong. I've never done this before, so this is just kind of my idea going based off of what I know of user interfaces, and so this might be a disaster as we implement it, but we'll fix it. And again, it's part of kind of what's going to be interesting of this. If nothing else, you can get some kicks out of watching me make a mess of this. All right, so let's do a simple proof of concept just of the fact that we can even get this to do something that looks like a user interface with the simplest element. And I think the simplest element, besides just printing text, is a button, right? A button would be, I think, in my mind, the simplest thing that we would need. And so, like I said, in an immediate mode interface, rather than having this designer that draws the button or that allows you to drag and drop the button onto the screen, instead you would do something like button, you know, this is the X, this is the Y. And, you know, this is my text. And, you know, generally user interfaces have something that allow you to do some sort of anchoring, is what it's usually called. So basically the idea is that if you have a button like you have OK cancel on your window here, or save cancel, right? Cancel, save. If you were to expand this window out, you want these buttons to move in the same direction as the expansion of the window. I'm not going to deal with that right now for this sort of simple example of a component, but then we probably want to be able to handle that, because obviously we should be able to resize the window and have the interface resize appropriately based on parameters that we're passing for the components. So this is kind of our minimum, right? We need X, Y, and text if the button is not a container in and of itself. And now it might be, and we would have to then allow that that whole sort of nesting process. But for the sake of this first pass, let's just make it work as a button. So generally, again, the way it works is you say you surround your button code with something like this, where you say if button you know, equals 1, then, you know, do something, meaning that if the button after it was rendered detected that it was clicked because the mouse was over it and the button was pressed, then that code should be called. And so you could see how this kind of makes a really simple way of triggering logic in the interface. So we're saying we need our X, we need our Y, we need our text, right? This would be the mouse button, which we obviously don't have right now. Mouse X, mouse Y. Oh, the other thing we need to pass it is the screen that we're operating on. This actually changes. The screen is not something we're going to pass later on, but just for the sake of the way we're doing this right now, we do need to pass this. So it's pretty straightforward to do a simple draw command. So you can do a fill and a rectangle. So we're going to fill a rectangle on the screen at the X and Y position. Now we don't have the width or the height, and the reason that we didn't pass it along is because the width and the height will vary based on the text that was passed in. So what we need to do is we need to say, okay, and thankfully it has this, you can say, I want the text width tfont, and I want the text height, right? Now eventually we might need a different font, but for now we're just going to use the default one because this is what it has. Now, well, let's run this after I draw my rectangle, and then we'll talk about what's wrong with what we have. So nothing too crazy here. We're just literally drawing the layers. So the font has a shadow, which is, and I don't want to use white because the button is white, so I'm just going to use a light gray for the text. And then the text is the text, and mouse button is not being, nothing is happening with that yet, so let's just initialize those guys to 0 for now, and then let's actually call this, and so if we got a button press, I want it to render to the screen right below the button, or roughly below the button. Let's just wait. Now keep in mind, nothing's going to happen. It's not going to print this text because we're not actually capturing the button presses yet, but let's take a look at this. So you can see right away the problem is that the text is squashed into that space, and that's because, you know, buttons normally have some sort of padding around them, but more importantly, it did draw it, right? It did draw the rectangle with the text on it. So, oops, whoa, that was full screen. All right. Let's fix that. So what we really want to do is a couple of things. We want to increase the button size slightly to accommodate some white space around the text so that it looks nicer, right? So it's really not, we don't want the width and the height of the text, we want something that's slightly bigger. So I'm gonna say I want 50% more, and then for the height, well, we'll do the same thing, right? And I'm just casting it to an integer, so the compiler doesn't give us a warning because I know that it's supposed to be an integer. That's fine. Now, what we need to do is we need to change this to be the button width and the button height, because we don't want the oh my dear Lord, what the hell is going on with my keyboard? We don't want the direct width and height of the text. We want the new button width and height. So you can see now the height is did I close it by doing that? That's weird. Why can't I read? Oh, there we go. doesn't show. That's weird. It was showing these buttons before, but anyway. So you can see it's bigger now, but now the text isn't centered in there like we would want. So how can we accomplish that? It's relatively straightforward. All we have to do is we say, okay, if this is the button size and this is the text size, what we need to know is what is the difference between this and the difference between that, and basically split it in half, right? That's going to center it. So we put half that white space on this side, and then the other half will reside on that side, and that effectively will just move this down into the appropriate location. So instead of it being this, we want to say, okay, button width minus width, and then divide by 2. And I'm doing the bit shift because, I don't know, because it's technically faster to do, and we don't care about floating point accuracy in this, and it's force of habit. And there we go. Now it's nice and centered. Looks pretty good. I mean, it's a button, but it at least sort of looks like a button. So now we would want to be able to have a highlight if the mouse is over the button, and then we also want to be able to press the button. So we got to get information from the mouse. So Tigger has this call called Tigger Mouse, and you get the mouse X and mouse Y, and then the mouse buttons, right? And if anybody has any questions about why I'm writing this code this way in C, let me know. I don't necessarily think I need to go into it, but if I do, let me know. And then basically what we want to do is we want to see if the mouse X is greater than the X coordinate and mouse X is less than the X coordinate plus the button width, right? So this is the same thing we were doing with the bounding boxes in the game, as we're saying we have this box, which is our button, and we need to see, is the mouse within the confines of this X coordinate, these X coordinates. And if it's not, then we don't do anything. And then if mouse Y is greater than Y, and mouse Y is less than Y plus button height, right? Then what we want to do is first we want to see if the mouse button is pressed. If the mouse button is pressed, then we want to, we actually have to change the order that we're doing this. We want to check the mouse first because it's going to affect the state of the button as we draw it. So we need to create something called dpixel fill color equals white, and then use fill color here. And then we say if the mouse is pressed. So if we're in this point, the mouse is within the confines of the button, and now the mouse is pressed, has the button pressed. So we want to change the fill color. I'm going to change it to dark gray, which we don't have defined here. Let's say, right, and then. Otherwise we're hovering over the mouse, right? Rather than clicking on the, hovering over the button rather than clicking on the button. So we'll set the fill color to light gray. And then what we need to do is we need to, let's see, if fill color, yeah, so what we can do is we can say, okay, if the fill color is still white, right? That means that the mouse isn't hovering over the button at all. Can you not compare these? No operator matches these operands. Ah. What is a t-pixel? It's a struct. Sure. Okay. So So if the color is white, then we're just gonna ignore the button, right? We're gonna forcibly set it to 0 because it doesn't matter what the state is. We want to return 0 because actually, you know what? That's not right either, because we don't want to. We don't care. It's not so much that it's not white; it's that it's not. Here, we'll do this. Return button equals mouse button. So, return button equals 0. So it'll only set return button to something else if the button is clicked. And otherwise, it'll just be 0. Am I overcomplicating that for some reason? That's the only time we care about the fact that it's been clicked. Otherwise, we're going to keep it 0. No, I think that's okay. So now if we run that, if we mouse over, it highlights, and then if we click, you can see the color gets darker, and then we actually have our little button press text showing up. So that looks like a real button. That seems to work pretty well. And then yeah, so I'm not crazy about the colors that I'm using right here. So I know that's trivial, but I just figure while we're doing this and trying to get something working nicely, what are the? Can I see what the RGB values of this is, please? No? Not going to tell me. Well, that's a bummer. All right, I'll just make something up. I don't care. It doesn't really matter. Green. It's going to be obnoxious green, but it's going to be green. So we'll fill the screen with green. Okay. So that looks like a real button, and then we can even do something crazy like if we wanted to have a bunch of buttons that we would need on the screen. We can even do, a loop of displaying the buttons, right? I times, I don't know what the height is, 25. Hey, we've got a whole bunch of buttons now. But what's cool about this is it's pretty straightforward. If you know what you're getting into, you understand what it's generating, right? There's nothing mysterious about it, and that wasn't that much work to get a simple button to work, and I realized that UIs are complicated, so I'm not saying that it's going to be that simple for everything. But you know, it also wasn't impossible to make it look reasonable, right, and behave the way that you would expect it to, and in a relatively short period of time. All right, so any questions before we start getting down to some serious architectural prep work here? Doesn't look like it. Okay. So, all right. So how are we going to do this? So, like I said, you know, we're going to have, it looks like some sort of tree structure, I guess, to represent the user interface. And we need that because we want to be able to nest controls. So I think to start out with, what I'd like to be able to do is have the ability to say, okay, if I have my window, I want to draw just a container, and within the container draw some text and draw a button. What is this doing? Draw a button that when you click on it, maybe destroys the container by changing the state of the user interface so that the container disappears, right? Almost like a modal dialog. So let's start with getting some things defined here. I'm going to just start doing it here in the code in the CPP file, and then I know we're going to have to start refactoring it into separate files. That's fine, just for the sake of expediency and not sitting here and trying to think of good names for things that don't exist. I just want to start coding. So, all right. First thing I think we would need to define is we would need to define, well, we need to define essentially a tree structure that can represent our components, right? So control tree. So let's think about this for a second. Or actually, instead of a control tree, I want to call this control node. And then we would have our tree root that represents the the actual UI component tree. And at the root would be the main screen itself. So as part of what you need, well, so you need the Tigger pointer, or is it Tiger? I don't know. It doesn't matter, I guess. And this is your, I mean, it's essentially it's a bitmap or a screen, or I don't know what we want to call it. Call it container or layer. Call it layer. And then I have our node count. And then thinking about what would be the best way to do this. So realistically, I think the best way to do this could we do that as a linked list within the node so that we don't have to. I'm just thinking about how we want to allocate the data structure for this, because there are a couple of ways you could do it. So you could say within a node you have your Tigger layer, right? So that's your layer. You have your count. And then you have an array of pointers to other nodes out there. And you could allocate those nodes as, as an array of the nodes. Or rather as an array of node pointers, and then you would allocate more than you would need. You'd pre-allocate, some fixed amount. Like let's say initially we'd allocate 10, right? And this count would actually represent how many we had allocated previously, and instead you check for if any of these are null pointers, and if they're null, then they're not used nodes in the array. And then if you fill up all your nodes in the array, you allocate a new bigger array. You get like 20, and then you copy your pointers over, and then you have more space over here. The other way that we could do that is we could just say, we just have a linked list of nodes where each node has this list of nodes that are children, and they're direct descendants of the parent, and then we don't have to deal with any of that stuff with this and the resizing. But then you have to traverse the list, and you can't. It's harder to do traversal in different orders unless you do doubly linked, where you can traverse back and forth. So I don't know. I'm not sold on either one right now. So I'm going to say, let's go with the array of pointers approach and see where that takes us. Yeah, so the username is nselecki. Hopefully I said that right. Yeah, I mean, I want to do this from scratch because, I think it's kind of cool to do it, and I think it'll be relevant and interesting to anybody who's working on this stuff anyway. Plus, it's to be honest, I'm going to have fun doing it, so I'm okay doing it from scratch. So, like I said, hopefully it'll either be interesting or entertaining to watch as a train wreck, and we'll fix it as we go. So, all right, so that's pretty straightforward there. I mean, we could do this as a class. I don't know. I don't want to get too heavily into object-oriented programming because it gets pretty complex pretty quickly. If we try to start doing derived classes and stuff, but I do like the constructor stuff. I don't know. We'll leave it as kind of pure C right now. Some of this, as I go, I know I'm kind of sitting here debating which direction to go, and normally, I would pick one direction or another based on the sort of the guidelines of the project, right? So when you're working on a project with a group of people, you generally agree it's like, yeah, we're going to be using classes and object-oriented programming, or we're not because of, whatever reasons that the team has for going in one direction or another. There's certainly been times where I've designed a bunch of things using object-oriented design methodology, and it has its advantage of it being sort of, in the cases where we used it, it was kind of slick because of the way that inheritance was used to do all of this sort of complex figuring out of what had to happen. But on the flip side, it gets pretty complicated to debug, and it's not as efficient as just using structures and function calls. And so I'm just going to opt for this for the sake of it being simple. And you can always refactor. Okay, so that's our control node, and that's our tree, and we've got our children defined. I don't know that we're going to need anything else. I'm trying to think about how this will come together in terms of clearing and drawing. No, I think that's okay. All right, so that's good. I'm going to move our button code down to the bottom because I don't want to look at that right now. I want to look at our main call, and we can mess with that in a little bit here. All right, so let's start with the beginning. So we've allocated our screen. I want the tree root to be the screen. So actually, well, see, now you get into this is why people get frustrated with I think one of the reasons people get frustrated with C programming, one of the many reasons, and C++ programming is that so the way I'm doing this, there's nothing technically wrong with the way I'm doing this. But the problem is that there are things you can do, for example, on Windows where you can allocate memory using not malloc, but the built-in Windows API calls, but that's not cross-platform, obviously. And if we want to do something that's going to be cross-platform at some point, well, then, ideally we would be using cross-platform calls like malloc, or other calls that, that are, at least in theory, cross-platform in C. But then there are advantages of using the Windows API calls in some cases. So, that kind of gets tedious and frustrating to have to manage. I'm just going to go with the sort of, again, simplest approach because it's going to work. I don't know that there are any real disadvantages of doing this. At the end of the day, the allocation and the zeroing of memory, it comes down to the same thing. I mean, it's all coming off the heap. So, how it behaves is obviously a little bit different depending on the call you're making, but we can, there are strategies for dealing with that. And if you really want to see, how that's handled in like a real world scenario, like a game, again, go take a look at Handmade Hero, because Casey has a couple of episodes where he's talking about how he handles memory allocation, where he's allocating essentially memory arenas that are used for storing information both permanently and temporarily, and he does that in a way that kind of abstracts the operating system out of the way, so that you're not ever dealing with malloc and free. Again, for this kind of a tool, I don't know that we care right now, but we may in the future, and we'll just fix it as we go. Hopefully it won't be too big a deal to do that. So, all right, I've got a tree root. I've zeroed it out. I've got our layer here. And then we're going to need, so let's do this actually. Let's make a call to handle this for us. Let's say initialize control node, and we pass it the layer, right? And it's going to get a control node pointer. Let me just cut and paste this code. And the reason I did this is because we're obviously going to have to allocate more than just the main one. So let's just start with that. Okay. So that's good. We got our tree root. We don't have to do this anymore because that is set up that way. Now we also need to do what I was saying before, where now that we have our tree, we need to effectively recurse down the tree, flattening the layers, right? So we'll call that render. And so what this is going to do is it's going to recurse down the layers, and well, so and then this gets to an interesting point of we need a little bit more information. So what it's going to do is it's going to recurse down the control node tree, and it's going to take the node layers, and first it's going to call render on the node, and then it's going to blit the layer to itself. Couple things we're missing is we don't know where we need to blit it to, so we should probably have an X and Y coordinate. And we also don't know how big it should be. So that would be useful too. Well, actually the layer, the width and height, let's leave the width and height based on the size of the layer of the child. We can do scaling and stuff later. I think that's I think that's good for now. All right, so again, oh, you know what we didn't do? We didn't do what I talked about. So we need to now set the children to a array of control node pointers. Let's say that we start with a size of 10. Let's in case we decide we want to change it. So we have our node count, and we've allocated the memory for our default node count, or the pointers to those nodes. So that's good. So that's that. X and Y would be 0 because we did the mem set. We do want to mem set the children So now those are some information here. So I remember why I'm doing what I'm doing. Okay, so now getting back to this, like I said, this is actually relatively straightforward. So we say if node is null, and just return. This is just a standard recursive call for a tree. So we want to say for I is less than node children. Nope. I called it node count, but I want to rename that to child count. Child count. Okay, so yeah, much better. And actually, yeah. All right, that makes me a little, I feel better about that. Okay. So now we're iterating through the children. And now, not all of these are necessarily populated, right? Actually, you know what we can do? I think this is a good way to do it. We say if render no children I. So basically, if we call render and it returns true, it's because it was actually a valid node that could be processed, right? It had something that it had something that we needed to render down. If we get false, then there was nothing in it, or maybe even there was some sort of error where it couldn't render it. I don't know. For now, we're just going to assume that it's null, and so then once we've got that, we can say Tiger Blit or Tigger Blit. Still don't know. Layer, and then node children I. So is this, yeah, so call this child layer, child destination X, child. It's getting real old keyboard. Child Y. Source X is 0, source Y is 0. Child layer width, child layer height. Okay. So to reiterate what I did here, we're looping through all of the children, right? So, right, we're checking each child, and if the pointer is a non-null value, render will have returned true, which means that it prepared its layer by rendering down its children if there are children that it had to render. Otherwise it would also just get false all the time because all its children would be null. Once we get a situation where render was true, we get the child into this child variable just to make it a little bit clearer what we're manipulating instead of having to say node children and then use the dereference to get to the to the layer XY and whatnot. So, and then we're saying, okay, we want to blit the layer of the child onto the layer of the parent using the child's X and Y coordinate. The source X and Y, so the X and Y coordinate of this layer's content, right? So if you think about it, within the layer here, right, this has a local coordinate of 0, 0, but then has to be rendered in this layer's coordinate system based on that XY value, right? That's what that XY represents. So just make a bigger example. If the child is going to be rendered in here, maybe its XY is 50, 50, but within this piece here, you know, things are getting rendered starting from here at 0, right? And then off to whatever the width and height would be. And it would be the same would be true if this outer thing was a child of something else. And then the width and the height, like I said before, we're just using the layer's width and height. We're not doing anything crazy with scaling or anything. So that would be sufficient to make this work. So let's start with just seeing if that doesn't crash everything. Access violation, writing location. Well, yeah. Why would you do that? That was a copy-paste mistake. All right, great. We're getting our same green screen green, which I'm going to change because it's awful. I don't know. Certain things when you're working, they bother you, and you just got to change it because otherwise it's going to bother you every time you look at the screen. Let's do... You know, he had in his example, he had a nice background color. What was it? 80, 90, A0. 80, 90, A0. Okay, so we're not broken. Okay. One thing I just realized, okay, so, yeah, so, okay. Sorry, I keep saying okay. One thing I just realized is that each of these layers should probably have their own background color, right? And the reason is because that when we go to render all of this stuff, we have to clear it. We have to clear the layer. So we would say node layer and then node background, right? So initialize control node, and we need to give it we should give it a background color too. So now we can give it this, so we're not constantly regenerating that. And then we don't need to do that clear screen anymore, because in the render it's going to clear it to the background color, so that should still work. And it doesn't. Why doesn't it work? It's calling render node layer is null. Oh. Well. So the tree root. Let's take a look at the tree root. The tree root has a background color. It's got a... Why doesn't it have... Why is it not storing the screen? Node, background color. Oh, because I'm just not storing it. I'm not saving it. Good work. All right. So that should be good now. Cool. All right. So that looks good now. All that work for essentially us doing nothing, but that's fine. Now, I just thought of something that I don't like. Actually, no, you know, it's not a problem. Never mind. Ignore what I said, or ignore what I was going to say. Maybe. Well, I just realized that using this, so what I was thinking about how this will work at each update, and I realized that every time through, so the big thing about the immediate mode-ness of this is that you're gonna, in the loop, you're gonna essentially call a function that creates, say, the button and adds it to the tree root. And the only issue I see is that, and we can tackle this later. The only issue I see with the way that I'm doing this right now is that it's going to have to destroy the child every time, because the point is that the immediate mode nature of the way that this works is that the children shouldn't be preserved for each cycle, right? That's the whole point of the way the immediate mode works, is that the state of the user interface is not preserved from update to update or from cycle to cycle, and that's going to get a little bit expensive to be constantly allocating and reallocating layers like this. I wonder if what I'm going to have to do is, instead of using layers, do essentially like function calls. I think that's going to work better, because allocating layers over and over, like the nodes themselves, that's not such a big deal, because it's just a small amount of memory. But the layers, I feel like that's going to be expensive, because that's probably bitmap resources that are tied to Direct3D in some way, potentially. Let's see. Is it possible to compile a C++ program into a game to NES? Just looking at the chat here, there was a question about if it would be possible to compile a C++ game over to the NES. And so, I mean, the answer is yes, but that's not what we're doing here. There are C compilers for the NES, and from everything that I've heard, they are not. You kind of have to use them very smartly. So what we're doing here is we're building a tool to integrate with the game for building assets and the world map and stuff like that. This is purely meant to exist on like a PC. This is not going to actually run in game. So, all right, let's go back to what I was saying here. So allocating the layers every time is probably not the best approach. What we probably want to do is have this represent a data structure that is more similar to like a function pointer and some parameters stored in here, and then the render call just gets the default layer or the screen layer, and it just renders. Yeah, I think that's what we're gonna have to do here. So so just to kind of explain what I mean. So let's say for the button, right? The button would just take a node, a control node, right? And no, let me back up for a second. It's not that the button would take the control node. It's when the control node is processed, what it's going to reference is the code that would be used to render the button into the layer in question, and it would receive with it data from the control node to know how to render the button, like what the text might be and stuff like that. So, all right. So for the simplest case of this, it's just a so we don't need that layer anymore. For the simplest case, it's just, you know, clearing the background. That's the root node. And yeah, so that's the root node, and then it would have a function pointer in here that calls essentially the code that renders the control, which would be like the in this case it would be just clear. So like clear control, or just background control, let's say, is the name of the function here, and it takes a void, or it returns a void, and let's say for right now it just takes the control node pointer. I don't know that this is going to say exactly this way, but I just want to kind of get this working, and then we can figure out what the right approach is. So this will be, let's create, I always forget how to do this exactly. So type def, or I don't always forget, it's just been a while since I've had to do it. So I want to define a function pointer type, so I don't have to keep typing out the long verbose. Oh, except that. Call this render control renderer. Not type def, just struct. And then I guess I reverse that order. I always do that. No, that was right. It's just, it doesn't like the formatting I used. Oh, no, it's... This is, I always get this confused because the syntax is so obtuse. All right, let's look it up because I don't remember. It's been a while. C function pointer type def. This is one case where something like C++ would make this a little bit simpler, because defining functions in C, like I said, it's kind of, the syntax is crappy, and makes it hard to understand what you're doing, but it's not really that complicated. Okay. Okay. That's good. And then that gets 2 parameters actually. It should go to Tigger. So take this back. So this should be okay. So well, let me finish coding this part, and then I will talk about what the hell I just did. So now it would need a width because the layer is not actually in here. Node width, node height, node background. Okay. So yeah, all that stuff is broken right now. Let's talk about this. So what this is doing is I'm telling the compiler I've created a type here called control renderer. It's actually a function that takes one of these Tigger pointers, and it also takes something called a control node. It should be T. A control node pointer. Which is this thing, and I'm forward referencing it using struct like this because I need control node T or control node to include the control renderer. So the compiler will figure out that this is this thing, and it will figure out that this is in here and needs that. That's not a problem, I don't think. And then I created a background control function here, which takes a layer and a node, and then it just does a simple fill. And this is what we're going to pass in for this. So now there's a whole bunch of stuff that's broken because we are no longer using the layer. So actually what we can do is we can say, no, that's fine. So initialize control node, the layer is no longer relevant. What we need to be able to do is we set all that stuff up. We've got the children, we've got the color for the background, that's fine. We don't need to pass the layer anymore. This is no longer relevant. Okay, so this is where it becomes interesting. So what it needs to do is it now needs to call child renderer. This needs to get what we're rendering onto, which is what it's going to pass, and then it's going to pass itself as a parameter. Okay, so what's the matter? Oh, yeah. That doesn't need to be there anymore. Oh, wait, no. So, sorry. We still need to do this for the top level one first. And then that goes away. And then, let's see. What is it complaining about? Argument type control is incompatible with render. Oh, right. So layer that. Okay. We don't need to pass that anymore. Here we need to pass screen. Unresolved external symbol renderer. Oh, freaking. change that to C because C++ does name mangling when it compiles, which was causing problems. A function type is not allowed here. Why? It's just a pointer. Function call is not allowed. Grr. Oh, right. So this is, yeah, this is just C being C instead of C++. So what I did was I switched the compiler to treat this as a C file instead of a C++ file, which we want so that we don't get the name mangling, and we're not using anything in C++ anyway, so we're not really losing out on anything in that sense, but it changes some of the rules about how things get compiled, and it broke some stuff. Okay. So let's see, renderer function cannot be a member of struct control T. Fine. It's a void pointer now. Right, so now that's what it's called, right? Casted type is not allowed. That's what I get for trying to do something I haven't done in a long time. So this is a void pointer. I want to cast it to. Do I have to? Wait a minute. Am I just? Like I said, it's been a while since I've used this, but let's see. This takes a signal handler. Yeah. And then it would just call. Yeah, okay. So let's see. What am I? Let me try something here. What did I call that function? Background control. So I should be able to just do that assignment. Is that just another case of me following bad advice on Stack Overflow? Eventually I'll find what I'm looking for. Yeah. That's not right. This looks like the same example as before. Type def. Yeah, I mean that all looks. Wait a minute. plain this time? Ah, okay. Oh, parentheses. I guess they make a difference, don't they? All right, so I just had defined this incorrectly. So that's why it wasn't letting me call this as, well, first of all, that's why it wasn't letting me use this as a type for this member of the structure, and then it wasn't letting me call it. It was just wrong. So what I want to do now is I want to create this tree root, and then basically I'm going to just say the renderer is background control. This is not the way we would do it. Normally, we would actually call the immediate mode function for creating the control, but just to start off with, let's see if we can make this work and be not totally broken. So if we go into the renderer, all right, so we got our layer, which is good, and we got our node, and the X and Y is 0. Oh, the width and the height are not set, right, because we added that and then we never put that into the initialize call. So let's do that. So let's see, where are we here? So 0, 0. Let's say that there's a special case for if you pass 0, 0 for background control, that if node width is equal to 0, and node height is equal to 0, that it's just going to be the layer width and height. Otherwise, and this might be a terrible thing to do, but I just want to see if we can make that initialize properly. So now we actually had a, no, we didn't have an actual width and height. Well, we did, it was 0, so that's fine because it has that special case in the renderer now. What am I messing up? I mean, the good thing is it's calling the background control stuff. The bad thing is it is not actually drawing X, Y. Oh, you dummy. You gotta actually use the width and the height that you set, or it won't work. There we go. So we're back to the very beginning in a way more complicated way, but hopefully that will now allow us to do the next step, which is we will add a child to this. We'll say button, and I feel like I don't want to have to pass the tree root. That's global anyway, so we're just gonna say button X, Y, and text. I think that's enough for now. So, all right. So now we don't have anything to create a button. So let's do that. And along with this button code, we need to create a similar thing like this, where we say we have, let's call this render background. So similarly to just having the call to add the button, we need to have something called render button, which will take the layer and control node. And I can sort of start to see how this is going to get separated out, where we're going to have controls and their corresponding renderers separately, potentially, just to kind of keep things organized. But that may change as we go. That's not a button, that's text. All right, so let's start off with just getting the button to appear on the screen where we want it to. The other thing we need to know is we need to know the main screen layer. And the reason we need to know that is for the mouse stuff. Tigger uses that. So let's do this. Let's see. Let's create a pointer called main window. And main window is equal to screen. And you might be screaming out, "Oh my God, you're using a global. You can't do that. That's terrible. That's a horrible programming practice." And to some extent, yes, it can become very problematic to be using globals. But if you think about it, what is the alternative, right? A static in a class somewhere. I mean, that's not really that different, other than you're organizing it within some sort of context of a class definition, right? But it's essentially global, right? Because you can be anywhere in your code and say class static equals whatever, right? How is that really any different than a global? It's not. It's not really. It's just kind of syntactically different. I mean, it gives it, again, that context where it's not going to conflict with anything, but at the end of the day, it's basically the same. And we're not using classes, so it's not possible to do it that way. All right. So we've got our render background. So here's our button. Let's do this. Let's start with just rendering the button the way that we would want to, so or the way that we were before. So we can actually just kind of grab that code from down here. I'm not going to do, I'm not going to render the text. I just want to do this. I want to say, we're going to create a control node. Yeah, let me do this first, and then I'll explain what my hesitation was. So control node, initialize control node. Let's get a background color. Well, we can just use the white color, because that's what we were doing. That's what we would be using anyway. I don't know. Some people use hex. I was using hex for it, but I just found myself naturally going back to decimal for it for some reason. The X and the Y. And then we need to know the width and the height. So let's do this. Let's do this here. Right, so that gives us our button control. And then the node renderer is render button. Right, so that would render the button. We have our width and height. That's fine. And then all we're doing here is we're saying we don't even have to do the background, because we know the button's going to fill the whole thing. So we say Layer node X, node Y, node width, node height, node. So we'll do that in white, and then we'll do a rectangle in black for the border. Right, so that's that. And now we're adding the button here. The only thing we really need to do at this point, actually, well, okay, I'm already jumping ahead trying to optimize this. Let's just leave well enough alone. So if we call this, we get the child. Let's say node children I is equal to null. We're going to render it, and then we're going to free node child. Node no, just child. So the reason we're freeing it is because, again, every time through we're going to be creating these control nodes for the interface as we build it up, each loop, like we would with, like we were kind of talking about with DRIM GUI. So let's see. And I know this is kind of crappy that we're freeing this every cycle. We can fix that in a second. What I want to do though is I want to test this out. So we do the render, we free it. It's already null in this list, so we're good. It's been freed. We don't have any other layers to free, so we're okay. I should free that layer for the screen down there. Okay, this is probably not going to work right. Okay, that's fine. Let's, oh, you know, yeah, it doesn't add the control node to anything, so that doesn't work. Add control node, current context node. We don't have anything called current context. And again, you know, I'm not sure that this is exactly the best way to do it. Maybe we decide we want to go back to doing stuff in C++ to be able to encapsulate some of these things into a parent class. I don't know. I don't know that it really matters right now. It's not super complicated to be dealing with it. So current context is equal to tree root. And the reason we're doing this is because when we do something like create a container, it's going to switch the context to the context of the container that we're working on until we're done working within the container. So when you place a container, we're going to do something like begin container or begin panel or something like that, and then you're going to be working on that thing, and then when you're done, it's going to go back to the parent context. So that might actually end up needing to be a stack. As we go, we're going to push them on and pop them off as we go up and down. But for now, let's get this working. So add control node current context. So let's see, where's my control? Okay, so add control node. Control node pointer context, and then node. And right off the bat here, to do add handling too many children by reallocating memory for the context. So I'm not going to deal with that right now. I don't want to have to deal with reallocating any memory. I just want to get this working. So context, so basically we say for int I is less than context child count. Even, you know, I might rename child count because it's really child capacity. It's not how many children there are in use, it's how many children can fit in the children array. I'll fix that in a second. So if context children I equals, if not children, so if it's null, then we can use that happily and set that to node, and we're done. And what I want to do is I want to, how do you do that? Assert, or I don't remember how to do this in Windows. I want to put a breakpoint. Is it assert.h? I want to force it. If we forget to do this, I just wanted to force the assert false. 0, right? Yeah. So normally you would want to test that an assertion is true. I'm just forcing it to pop out of here, forcing it to hit a breakpoint here if we couldn't find a spot. Just wanted to hit a breakpoint here if we forget to come back to reallocating, if we have to do that. And I'll just call this capacity, child capacity. All right. Hey, all right, so we have a tiny button there. The question is it tiny because I'm passing the wrong width and height to it? Yes, I'm giving it the width and height instead of the button width and the button height. And that should be okay. That's better. Obviously there's no text right now, but we'll get to that in a minute. That was a lot. Let me stop and see if anybody has questions. And so lucky I need to go to bed. Okay. Yeah, this one, as they have been, is running a little bit long. Anybody have any questions about what I did here? Well, type it into the chat and I'll get to it. Hopefully everybody's following. So we're at a point now where we've got this control node being populated. We don't have the ability to draw the text in there for the button because we have nowhere to put it. So basically what it comes down to now is how do we deal with arbitrary data for these controls? And I think basically what we would want to do, what I think we would want to do is have essentially a buffer of memory that could be for whatever we need. So it could be text, it could be whatever it needs to be. It could be a pointer if it's something more complex. Hopefully it wouldn't come down to something like that, because it would ultimately start to become very expensive to keep doing this rendering. But I'm thinking what we can do just really easily is we can say, we have a buffer of arbitrarily, right? Just 100 bytes. Actually, let's call this control node buffer size as 100. And that's and that's going to be, because that's just a fixed buffer, the memset will clear that out like we want it to, or like we would hope that it would. And then, so we've got the text, we've got initialize control node, we have our node, and then we want to set the text in the buffer, right? So let's say, oh, Microsoft, are you doing string s? What is their, forget what their version of this is. I should be able to just do string. Oh, okay. So two things. String.h would be helpful, and then string and copy, destination buffer, source buffer, and then control node buffer size. So we're just using string ncopy so that we only copy as many bytes as will fit into the buffer. What is this saying? This is saying, oh right, yeah, use string copy s. Destination. Well, I mean, if I knew the size, all right, I'm just going to ignore that warning for now. Fine, Microsoft, fine. So it wants the size of the text that's coming in, as well as the, so these are, let's see, number of elements, forget how this, size of the destination string in characters. So this is this is that, and then we have our thing, and then what was the, and then the max is, or the count, number of characters to be copied or truncate. Yes, that's what I wanted to do. If it's too small, you just truncate it. That's fine. Okay, so now we're copying our string into buffer. And what we need to do now is we need to draw the text at this point. So T font. Now we can calculate our x, y, width, height. So we need the text width and the text height as well. So text width is equal to what is it? Text width, yeah. And then the height is this. So this is really basically the same as what we were doing before, where we're getting the only difference being that we are doing this in a function call that's being called by the renderer function rather than by just a call to directly render it. So we've got print. What is the next thing? We need the x. So we've got the x, the y, the color. We'll just do the darker color that I was using before. And then we have the text and that. And then we actually have to initialize these so that I'm not calling node dereference every time. Especially if we're going to be using this. Multiple times here, so x, y, width, height, x, y, width, height, and then this is just x plus width minus text width divided by 2. Same formula we were using before, where we want to center the text. Height minus text height divided by 2. There's our text. Cool. I'm going to make that text a little bit darker. Actually, that's too dark. Now, obviously, we could add something to control the color of the text to the control node, but I just wanted to have it be fixed for the button for now. Okay. So the other thing is, this is that right? Yeah, that's right. Okay. So let's do this. Let's change this text. And let's handle the mouse, and then let's call it a night. All right, so we're not handling the mouse at all right now. Now, the mouse handling stuff has to be done in this call, so we actually have to make that an int that it's going to return. So what's kind of interesting about this is that we're doing essentially we're doing this sort of weird split way of handling it. We have the call here to create the control structure, the control node for rendering the button, right? But we also have the logic for checking whether or not the button's pressed or anything like that living here. And so that's going to have to propagate into the control node in some way, but let's start with just handling that first, handling the button itself first. So let's get the mouse position, and we're getting it of the main window. We have the X, the Y, and the buttons. X, Y, buttons. And now we say if, oh, we can't do that because we already have those as parameters. Okay, so if the MX is greater than X, same code as before, and MX is less than X plus button width. And we just do the same thing for Y. Changes the height. That's not the variable name. Then we want to return buttons. Otherwise, we want to return 0. So if this, oops, what did I miss? Oh, close paren. I missed it here then too. Did I miss it? Did I miss multiple? If, and this, oh, wait a minute. That's that one, okay. And then that's that one, and that one, okay. What's the problem? Initialize local variable, oh, yeah, and then we have to take that, okay. Right, we actually have to set that, and then let's just do a simple thing here where if the button is pressed, we're just going to, I don't know, it's not, oh, because that's a Windows H, yeah, just do this, pressed. So we'll just print that the button was pressed. Now there's going to be no visual feedback within the interface, but you can see that it's detecting that we're clicking on the button. So that's good. So now what we want to do, so now this is going to get a little bit tricky because basically what we want to do now is we need to start using the buffer in a slightly different way. I think what we really want to do, instead of having this be buffer, we want to do something like this. All right, and what we're doing is we're creating a new structure called button, and the first member of the structure is the button state, and then we have the text, and this is control buffer size. And then, instead of this just being so instead of this being just, oh dear Lord, instead of it just being a sort of unorganized group of memory, what we want to do is we want to have, we're going to use a union here where depending on the type of control it is, it will use one of these members, right? What's the matter? Function button is not, oh. Do I actually have, oh. Fine, we'll call it button data. Button data. All right, so what this is doing is it's setting up an overlapping area of memory where we can have a bunch of different data structures that hold the different data for the type of control that it is, so that we don't have to be doing weird pointer math to get what we need. We just reference it appropriately depending on the type of control it is. So obviously this is no longer going to work. What we would say is we would say node control type. We know what the control type is. It's we want button data, and then, well, let's do this. What we really want to do is we want to say button data pointer data is this guy. And then we can say button. No, not button. Text. Right, so that's got our text in it. And then, depending on the button state, that gets put into the control node. What's the matter with this? Let's Oh, because that should be a dot dereference, not an arrow dereference. Text. Then depending on what we do here, then we say, okay, node button data button equals buttons, right? Or node button data button is 0. So we're actually now passing the button state depending on if it was moused over and pressed. We probably need to add something about whether or not it's being hovered over, but we'll get to that in a second. What I want to do first is get the rendering here to look at the button state. So tpixel fill color equals, let's change this. Let's say this is that. So under normal circumstances, it's going to fill the button with the color white. But if data button equals 1, which will only occur if the button is actually pressed, essentially, that's the button's state, then we're going to change the fill color to be a darker color. Let's change it to be something like 100, 100, 100. So now we should see at least visual feedback, not for the hover, but for the actual click. Yep. All right. So now we actually see a button click. And then finally, what we want to do is we want to add whether or not it's hovering, right? And hover is defined as basically we're at this point, but the button equals 0, right? If buttons equals 0, then node button data hover equals 1. And so then let's do this. We don't care about hover if the button is pressed, but we do if it's not. We want a slightly lighter color. So say 200, 200, 200. Where am I missing my semicolon? Else, oh yeah, else if, right? And that's misspelled. And now we should get a hover change. Yep, so it's hovering, and then if I click, it's pressed. All right, so now we basically have the same thing as before, but with a little more organization to it. And I should be able to do this. I should be able to say we have 2 buttons now, and they are discrete. Cool. All right, so going back to what I was saying before, this free, probably we don't want to do this. What we probably want to do is have something in the node, the control node itself, that just indicates whether it's active. That way we're not allocating and freeing nodes over and over again. I mean, it's just better for performance-wise. It's also creates memory fragmentation to be allocating and freeing things over and over and over again. And while this is not something that is generally going to be, running for, it's not a server application where it's going to be running for days, or something like a game where you have, well, maybe, I don't know. I mean, it may be that we're using this for hours on end, and we want it to be pretty robust. So the point is, at the end of the day, that I just, excuse me, I want the memory in the children to be allocated once, initially, and then the only time we would reallocate any memory having to do with anything is if we find that the control node array is too small to handle the number of children we're trying to put into the interface. But we're not going to do that tonight. So that was a lot of work to get a user interface where we can render 2 buttons, but this is the foundation where now we can start adding new additional structures. So we can start adding panels and containers where we can place the buttons within that, and then, like I said, we get that ability to do this rendering down, iterating over this tree structure that, it's not even a binary tree, it's an n-way tree, where we might have, potentially hundreds of controls in this thing, and it's going to be just kind of boiling it down to the final output on the screen through the use of these render functions. So I think the next step is we probably want to start separating out the render functions and the control functions for the control nodes into 2 separate files that we can bring into this, so that we're not cluttering up the main application with that. Because in here, what we want to do is we want to start building the actual application that will let us create a project, essentially, where we're managing assets for the game, right? So we want to be able to bring in assets like the images and whatnot, and manipulate those and have the UI reflect the state of what we're doing within the project, rather than handling and we want that code to be concentrated here on that task, rather than having all of this GUI stuff sort of intermixed into the main code here. Hopefully that made sense. So that's where we're at for now. Any questions before I wrap it up for tonight? All right, well, as I've said, I'll be posting this recording, as I have with all the others, on YouTube. I'll put the link here in Twitch so you can find it afterwards. If you have any questions, you can reach me at Clairvis on Twitter, and I'm on the Nintendo Age Discord chat and forums. And hopefully this was a start to some real progress here on this asset tool. Obviously, the GUI part is going to still consume a lot of our time, but it's kind of been fun building that. And there's a lot more to build, but that's okay. That's kind of what I expected going into it. So yeah, hope you enjoyed the stream, and we'll pick up on Monday at 9 p.m. Eastern. And if I don't talk to you, have a great weekend, and I'll see you next time.